Suppose that the row-reduced echelon form of square matrix A has at least one all-zero row. How many solutions are there for the system AX equals 0? The homogeneous system here. Okay. So the trick to applying the fundamental theorem of invertible matrices to help us for a question like this, and we really do have to use theory because I have no idea what A is. I don't even know its size. I know it's square, but, is it a 3 by 3? Is it a 10 by 10? We're at a loss. We don't have actual numbers, entries to work with, so we do have to use some theory here. And the way to use the fundamental theorems is this. You take what you were given, and you find a way to connect it to one of those 5 statements from the result. Maybe connect it to statement number 1. And then, once you know that this is true or false, you connect it to another statement, maybe 5, and so it will also be true or false, and then you use that to talk about the thing that you want, the thing that we're asked about. Okay? Now, what are we asked about here? We're asked about homogeneous systems. Is there a result in the fundamental theorem of invertible matrices that talks about homogeneous systems? Well, yeah, number 3. And for the record, you don't actually need to memorize which ones are which. You just need to know the statements and that they're all connected. So is there a result about solutions for homogeneous systems? Absolutely there is. Statement 3. Okay. Now, what are we given in the question? Suppose that the row-reduced echelon form has at least one all-zero row. Let's try and imagine what we've got here. We've got our matrix A, and we row-reduce it. And I don't know exactly what it's going to look like. It's a big square matrix, but they're telling me I've got at least one all-zero row. Did they say at least, or did they say exactly? At least one. Okay? So that's all I'm being given. Now, there are statements in the fundamental theorem of invertible matrices that talk about row reduction. Okay? So we might remember, I think it was statement 5 that says a row reduces to the same size identity. But could this matrix be the identity matrix? Well, no. If it was the identity, you'd have a 1 in this last row. You don't have any all-zero rows in the identity matrix. So what they're trying to tell us in the question is that statement 5 is false. A does not row reduce to the identity matrix. But as a result, if one of those statements is false, they're all false. So statement 3 about homogeneous systems is false. What did statement 3 say? Statement 3 says that AX equals 0 has only the trivial solution. So only the one solution x equals 0. So I now know that that must be false. Okay. So this homogeneous system doesn't have only one solution. But it's a homogeneous system. So it must have infinitely many solutions then. And in that way, we were able to answer our question. How many solutions are there for the homogeneous system? Infinitely many. Notice the chain we used. We took what we were given. We found a way to use one of the results. We used V. Sorry, not V. 5. And we found that that was false. Okay? And we connected that to a more useful statement, the third one, and we said, well, that must also be false. And then we used that to work out the result they were asking for, do the calculation they wanted.